Okay, so we finished part one of variables on both sides. This is now part two. So the other thing that we want to talk about when we solve equations is these couple of scenarios coming up. So let's just go ahead and start solving, and let's just see what happens. So as we talked about on the front side, the very first thing we want to do is combine everything on the left side, everything on the right side. Well, both sides are completely combined. So then we can just start bringing our variables together. So that would be the second part. So again, remember we have a negative 4x. So with a negative 4x, what I want to do is I want to add 4x to both sides to move them together. So when I look at the left side and I add down, I get 3. Notice that negative 4x and plus 4x becomes 0x, which is 0. Then on the other side, when I go to put that together, I first have the negative 7. Then, wait a minute, I have negative 4x plus 4x again. That becomes also 0x. So those cancel. So now what do we have here? So notice there are no more x's. The variable is completely gone. They've canceled on both the left side and the right side. So what is this telling me? Basically what this is telling me is, looking at that bottom line, does 3 equal negative 7? Well, hopefully we are all okay saying it does not equal negative 7. So we put this little line through, that is the not equal to sign. And the way we answer this is that there is no solution. We can't say the answer is 0. We don't want to say the answer is 3, and we don't want to say the answer is negative 7. When the variables completely disappear in our work on both sides, and we're only left with regular numbers, if those numbers are not the same, we say no solution. Meaning, whatever you plug into that equation for x, it will never equal, and we know an equal sign should be equal. So let's look at the next example. So the next example, we have to do a little bit of simplifying first. The left side is fine. The right side, though, we can see distributive property. So again, outside number times the first inside number is going to give me first 12 over 2x, but 12 over 2 is 6x. And then I do 4 times 1 again to equal the 4. On the left side, I'm just bringing that down because it's ready to go. So again, we notice we have variables on both sides. So I draw my little line. The first step is, let's get those together. So I would subtract 6x from both sides. Notice what happens. On the left-hand side, there's the 0, leaving me with a 4. But again, 6x minus 6x cancels, which is 0, leaving me with a 4. So, if the variables are completely gone, just look at that bottom line. Does 4 equal 4? Now, hopefully you would say yes. And when this happens, we don't say no solution. We don't just say 4. We say infinitely many solutions. Basically, what that's telling me is that this equation, no matter what I plug in, is always going to work. I can plug in any fraction, any negative number, any decimal. Even the number 4 will work, but infinitely many solutions means everything will work. So those are two that we got to pay attention to. If the variables are there, when we move them all together, there'll be one solution, and we solve for that variable. When the variables completely disappear, which we got to be on the lookout for, if the answers on the bottom, those numbers are the same, it's infinite. If they are not the same, there's no solution. So now we want to look at these last two examples. So we are given these two circles are identical. So that's kind of important to notice. These are identical, which means everything about them is the same. Then the question is, what is the area? And that's going to be important later on, of each circle. So what do we know about area and circles? So maybe you remember, maybe you don't. The area of a circle's formula is pi r squared. R representing the radius. Remember, radius is halfway across the circle. So looking at that purple one, the one on the left, if I first just kind of focus on that one, we're given the diameter. I'm not given the radius, I'm given the diameter. So to find the radius, I would have to cut that in half. So 1/2 of 4x is 2x. So I just got to keep that in mind for that the purple one. The radius of the green one is given, x plus 2, so I know what that radius is. So I'm going to create an equation. If these things are identical, that means the radius here is the same as the radius on the purple one. So if that's true, I can say that 2x equals x plus 2. The radius of the purple is 2x. It equals the radius of the green, x plus 2. Now I can just solve. So what I would do is subtract x from both sides to bring the x's together. X equals 2. Is that my answer? Because I see it as an answer for A. Is this my answer? Well, let's see what the question says. The question wants to know what is the area. So is this the area? Well, no. What we were doing is figuring out what is the x for the radius. So we do not have that yet. So first of all, we only have x. We need to know what's the radius. So if I go over here and I plug x in here, 2 times 2 is actually 4. So a couple of steps here. So first, we now know that the radius is 4. Then I need to take that, so there's several steps on this one, and plug it into here to find out what is the actual area. Because again, the 4 is right here, but I need to find the area of the whole shape. So I got to do one more formula. So I'm going to go back to my area over here. I'm going to leave pi symbol just the way it is. I'm plugging in the 4 with the exponent of 2. Do you remember what that does? Remember, it's not 4 times 2, it's 4 times 4, which is 16. And the pi would go in the front. So typically, we would write the number in front of the symbol. So I'm just going to switch it around real quick to get 16 pi. That is one of these answers. I don't know why it's coming up with this. This should be pi. 16 pi is your answer. And on the last one. So what we do here is we see a boat. It's traveling upstream. It's traveling upstream, and it is traveling X miles per hour. Then on their return trip, it's traveling faster. So we need to know how fast it's going. We also want to know how far is the boat traveling. Well, if you look at the picture, we can clearly see it's the same distance on the trip. It's going up some distance and then going back the same distance. So I'm going to use this formula here that you may or may not have seen in the past. Distance equals rate times time. Rate is our speed, okay? So one thing I want you to notice here is the distance, I'm just going to abbreviate it, upstream, like we just mentioned, is the same as the distance downstream. So that's important to notice. So because of that, I can basically set up my upstream distance, which would be r times t. It's equal to the downstream distance, which is r times t. So what do I know about these things? Well, I don't know the speed, so I'm going to leave that as r. What I do know on the upstream is that it's 3 hours, because t stands for time. The downstream, I don't know what the speed is, but what I do know is that the speed coming back down is 2 miles an hour faster. So with that in mind, I can say, I don't know what it is, but it is 2 miles an hour faster than the other side. So let's say R was 5 miles an hour, it's now 7 miles an hour, so it's faster. And I also do know the speed, the time, right here, downstream, is the 2.5. So there's my equation. So now I just use my distributor property on the right side. I'm going to bring this 3 in the front there. I would just kind of do it backwards here to get 2.5R to get plus 5 there. Then when I move my steps, I bring my R's together. I'm going to subtract 2.5R from both sides. 0.5R. And on the right side, 5. To break apart that which says multiply, we would divide 0.5. Now be careful here. This gives me my R. 5 divided by 0.5 is not 5 cut in half. 5 divided by a half is actually 10. Again, though, that's not my answer. We want to know the distance. So I'm just going to plug it back into that upstream one. So the distance, the R is now 10 miles an hour. The time was 3 hours. So my distance was 30 miles. So this is the end of part 2 of 1.3. Do the best you can with it. Watch out for the thing when the variables disappear. Save any kind of questions you have. Make sure you ask the next time I see you, and we'll talk to you again shortly.